So in this lecture, we're going to go over how to make a decision tree classifying algorithm. Now I'm going to start out by going to my Google Drive environment and creating a new Google Colab. Okay, and I'm going to name this assignment 07 decision trees. And I'm going to be using the iris dataset. So first I'm going to make a new section header. I'm just going to call it import for us to import our data. And then I'm going to import pandas so we can manipulate our data. And then I'm going to import Seaborn so that we can get access to the iris dataset. And I'm going to create a new data frame. I'm going to load that data frame from the Seaborn library, and I'm going to load the iris dataset. Okay, and now we have our data. And let me just walk you through a little bit of what we are going to be doing, or what the objective is with this this exercise. So we previously did regressions, and if you remember, doing a regression is where you have a quantitative target variable and use all the other variables to try to predict that quantitative target variable. Now with classification algorithms, instead of looking at instead of predicting a quantitative variable, they predict a categorical variable. So for this exercise, we are going to be trying to predict what species a flower is based off of its sepal length, sepal width, petal length, and petal width. And we're going to use a decision tree algorithm to do that. There's many other types of classification algorithms, like support vectors, also another popular one. However, I like the visual appeal and how intuitive a decision tree algorithm is for classifying, so I chose to do that one for this exercise. And when I think it'll be a little bit easier to explain a little bit later in the exercise, how a decision tree works once we get to the model fitting, so I'm going to save that for there. But now continuing on, we are going to, now that we have our data imported, we want to clean our data. And call this section data cleaning. And couple things we want to know before we can feed a data set into the algorithm. We have to do a couple things. We should get rid of any missing values or fix any missing values that are in a data set. We also need to convert all categorical variables to dummy variables, and we'd also need to get rid of any index or name features. For instance, it's not listed here, but say like this was listed as another feature called index. I should remove this index before I would get into my data cleaning. So first thing we're going to do is we're just going to find what our target variable is. I'm going to say target is equal to species. So I'm just throwing that up there. The next thing I'd do is I'd want to get rid of any names or indexes. As you can see, this data set doesn't have any names or indexes, so I don't need to drop any columns. But if you're working with the data set that does, make sure you do that. Also, I want to drop all NA values. I'll do df drop NA, and that will get rid of any missing values. It'll find if there's a missing value in a row in the data set, it will drop that. Now the iris data set is very clean and it doesn't have any missing row or missing values, but other data sets you might have to worry about that. Now that I have that established, I am then going to determine what my Y is, or what my target array is, and I'm going to set that equal to target. And if you see now that I have all my y values, which is the different species, and then lastly, I'm going to want to set my x. So x would first be set equal to df.drop columns, and then we want to drop the target variable. However, in addition to dropping the target variable, we also want to, it won't matter for this data set, but we'd also want to turn any categorical variables into dummy variables. This only has quantitative variables, but if it did have categorical variables, we'd want to do that as well. So I'm going to just add the additional step just for safekeeping of get dummies. And if we do that, you see it doesn't do anything to our data set. But let's say, for instance, we didn't have any columns that we were dropping. Then if we kept the categorical variable, it would split it into dummies for us. I'm going to get rid of that, and then I am going to set this equal to our x. Run that, and we should have an x. So now we have our y, our target data, and then our explanatory data. So I'm going to get rid of those two, and then the last thing we are going to need to do is we want to split this data up into a training set. So from scikit-learn, I'm going to add model selection, and then I'm going to import train test split, and then I want to make xtrain x test y train, and then y test, and then I'm going to call train split, and then I'm going to run that on our x and our y data, and then I'm going to set the test size equal to 0.5. And the reason why I'm using such a big test size here is because with decision trees, they can easily overfit a model. So typically it's a little bit better to use a bigger training or a smaller training, have a bigger training set, or I'm sorry, a bigger testing set so that you can better evaluate the model. You can also get into using cross validation and folding. However, that's outside the scope of this class, and we won't be going over that here. We're just going to be using a bigger test size. Now that I got our data split up between a testing and training set, I can then go ahead and start to do analysis on our model. So let's go ahead and create a new section, and I'm going to call this new section analysis. And now I'm going to import from sklearn.tree, and then I want to import decision tree classifier. And then I want to make my model, and then I am going to want to fit that model. I'm going to set my model to decision tree classifier, and I'm going to fit it to our x train and our y train data. So now that I have my model trained, I want to go ahead and start to predict values. So I'm going to make a new variable called yPredict, and I'm going to make that equal to our classification model. I'm going to use the predict attribute to then create predictions based off of our testing set. If you do that, you see it'll return to me a list of species. And then something we can do actually before we get to that, I want to show you guys under the hood what is going on with this model. You do not have to do this, but I like to do this just for visualization. We can actually display what the decision tree looks like. So I'm going to do that really quick. I'm going to import image, then from import image, then from scikit-learn, I'm going to import tree and import export graph viz, which will allow us to turn this tree into a graph. And I'm going to call the graph viz library. I'm then going to create something called data.data that will allow us to graph this. And that's going to come from the export graph that we called up here. Then we'll enter our model. We'll define what our out file is. Right now we don't want one. Then look at feature names, and that's just going to be equal to the different columns of our data. And we want to get class names, which are going to be equal to the unique values from our Y data. Finally, I want it to fill in. This is just to make it look pretty. I wanted to use special characters. Okay. Hopefully that works. Okay, now that we got our dot data, we can then turn that into a graph. Just going to set graph equal to tell what the source of the data we're getting our graph from. And then finally, we want to view what our image will look like. I'm going to go to graph, this object that we created for graphing, and I'm going to call it iris, and it's going to be in the format of a PNG. Okay, so if you go ahead and run that, you can see that we now have our decision tree, and I'm just going to open this up in a new window. So explaining how this algorithm works, what this algorithm will do then is it'll first look at petal width. And if petal width is less than, if petal width is less than 0.8, then it'll automatically classify it as a setosis. If it's greater than 0.8, then it will then move on to this node. And if it has to choose at this node, this is its best guess. This class or this species is its best guess. But it'll then look at the petal width. And if the petal width is less than 1.65, then it's going to classify it as a Verisi color. If it's the petal width is equal to though or greater than 1.65, then it's going to classify it, and then it's going to keep moving down the tree. And so this is how a decision tree algorithm works, and how it's able to determine how to make predictions on data when classifying our testing data. Now, you don't need to do this, but I think this is a little fun thing to do just to see what's going on underneath the hood with our algorithm. But coming back here, so we predicted the species of our testing data. And now what we want to do is go ahead and evaluate this, our model, to see how well it performed. So I'm going to create a new data frame called model output. And then our data is going to be equal to, I'm going to say prediction is equal to our y predict, and then actual will be equal to our y test. And then we can go one step further and create this new column called error. And it's going to be equal to where model output prediction is equal to model output actual. So if these two are equal to each other, it's going to return true. If they're not equal to each other, it's going to return false. And then we can look at this data frame. So you can see this is the predicted value, and then this is the actual value. And for the most part, it classified them correctly, but every once in a while you see here that there's a false classification. So if we want to go ahead and measure the accuracy of our model, what we can do is we can take the model output error and we can sum that. And if we sum that, Python stores trues and falses as booleans, which means they are ones and zeros to the computer. So if we take the sum of everything, then we're taking the sum of all the trues and we're adding that up because the zeros are only equal to false. And then we can divide that by the count of the data frame, which is the total values, and that should give us what the accuracy of our model is equal to. Okay, and there we go. We see that our model is 0.86% accurate, which means that it got 86% of these labels correct. Another way I can also get this accuracy score, instead of going through it and doing it manually, I can go to scikit-learn and I can import metrics, and then I can use metrics.accuracy score, and I can then import our y test and our y predict. I'll just make this equal to accuracy. And you can see if I run that, I get the exact same value. So this is just telling you what this function is doing here. But normally it's just much easier to pull the metrics from scikit-learn using a function like this. And then finally, if you know statistics really well and you really want to dive deep into what the error is in the data, you can use this classification report. And if I run this, you see that I get the precision, the recall, the F1 score, and the support for all my different for all the different species, as well as the overall accuracy, and then some other metrics. Now, these metrics are outside the scope of the class. On the assignment, I'll have something posted explaining them, but but the one that we're going to focus on for this exercise is just accuracy. Another thing I can do to help me better understand what is going on is create something called a confusion matrix. So let me import matplotlib. I'm going to import Python plot as plt. And then I'm going to make a confusion matrix, and it's going to be equal to the metrics dot confusion matrix, and then I'm going to run that on the y test and the y predict. That'll make our confusion matrix. Then I want to display this matrix. And then I'm going to use confusion matrix display. I'm going to import our confusion matrix, and then as display, I am going to set it equal to labels. And then our labels are going to be our species, which will be the unique y variables that we get. Finally, I want to display this matrix. So I'm going to import display. I'm going to plot. I want to plot the values. Format equals D. And then I'm going to show the plot. Oh. Go. There we go. And now I get my confusion matrix. And so just to show you what is going on here, what we have is this is the true label on this axis, and then this is the predicted label. So what this means is what this means is when it predicted setosis 26 times, and of those 26 times, 26 of them were correct. However, over here with Versicolor, as you can see, it predicted correctly 19 times, but 9 times it predicted the wrong species. And then for Virginica, it predicted Virginica 20 times out of 20 times right, but there was one time that it mislabeled it as Versicolor. So this is a great way to kind of understand your error in your to understand the error in in your model and how you might be able to improve it or what's going on. And then lastly, if I want to extract this data so I can turn this into an Excel graph for a slide, I can then just go to Google Colab and import files. Sorry, first before I do that, I need to turn this into a data frame. So I'm going to create a new data frame. We'll make a new confusion matrix data frame and make that equal to pandas.data frame cm, and then I want my columns will be equal to y.unique, And then my index will also be equal to y.unique. And so now I have this data frame. I just need to remember that my index is the true labels and my columns are the predicted labels. Finally, I can then export this as a CSV file so we can interact with it in Excel. Yes. Okay, and then I open that. And here we have our data frame.